And we're recording. So welcome to the third session of our class with Ms. Sunny Ware, our pen test, web app pen test class. If you are watching this one and you haven't seen the other two, there's a playlist in our YouTube channel here where you can look at the first two classes ahead of time. So this is going to be a longer class than the first two, so we're going to go ahead and get started. So take it away, Ms. Sunny.
Okay, thank you, Brian. Okay, let me just... All right, so welcome to session 3. What I'd like to first do is go through the solutions for last week's homework. Now, what I've done in this slide deck is for all of the exploits that we're going to be doing, I've added a special little star in the corners of the slides to help you better understand what it is that we're actually exploiting. So you'll see that that's sort of to focus your mind on exactly why we're doing this challenge and what vulnerability as a pen tester you're looking for and that you would include inside of your report. So hopefully that will be helpful as we go through these. So the first homework challenge was to find a language file. Now the challenge words itself, it says retrieve the language file that never made it into production. The interesting thing about this challenge though is if you look at what are we abusing, we're abusing dead code. So in a lot of situations, developers will leave code, that isn't actually called, but they'll leave it. They'll leave it in the stack. They'll leave it in their stack as far as what gets loaded onto the stack in memory. They'll also leave files that aren't used anymore. Maybe they make a backup of the original and they make a slight change. So this challenge is designed to help you sort of find those gems and write it up as a vulnerability, right? So this would be something where you found a file that was deployed to production, but it wasn't actually used. So let's go ahead and do this challenge together. Now, the easiest way to do this challenge is to focus on the languages here. So I'm just going to switch to German, and I'm going to switch back to English. And I do have my proxy, Foxy proxy on. So if I go to the proxy tab and I go all the way down to the very last call, which is where I changed my language file, I'm going to go ahead and send this over to Intruder. Now, I'm not interested in changing the cookie, so I'm just going to clear that substitution field. What I am interested in changing is this language abbreviation. So I'm going to add my substitution field around that. I'm going to go to my payloads. I'm going to use a simple list. I'm going to load a language codes.txt. Now I actually created a smaller version of this just because we're using free and wanted to get to the language of interest quicker for demo purposes. Now, the other thing I wanted to point out is I'm always having you uncheck this URL encode these characters box. I want to take a moment to explain why. There was some talk in the web app channel about bypassing WAFs. If you are in a situation where you want to send some payloads, say it's SQL injection, you could URL encode the payloads, and what that does is it's going to disguise your payloads much better. So if the WAF is using a blacklist, which a lot of them do, you would probably be able to bypass, so it's worth a try. But what this does is it's going to use these URL encodings on all of the items inside of your payload, so keep that in mind. Now, for our purposes and for this particular challenge, we don't need to do that, so that's why I'm unchecking it. I will get to Unicode and different character sets tonight because it's a vulnerability I want to talk about. All right, so we've got everything set up. Let's go ahead and start the attack. Okay, and so right away, I've got a hit. If I just take a look at my status codes, I can see I've got these 200s. But what's really interesting is for the 200s, I've got one set of lengths, but then I've got a different set here. I've got a different value here, rather. And so that's really the one of interest. So if I take a look at that response, you'll see that I actually have a language identified. So that was the purpose of that challenge, is really to have you try to find dead code. And in the pro version of Burp, there's something called, which it's grayed out for you here, but there's something called Discover Content. And Discover Content, which was actually in one of the homeworks I gave you, the picture that I was showing you is from Discover Content. It allows you to have customized word lists, but what it also does is it will look for basically dead files. It'll look for files on the system that may have like .bak or tilde at the end, you know, commonly used file names and extensions, and try to find those for you. And you can customize it, of course, with your own word list. So that's just something to keep in mind if you needed to do that. I have actually found some things that way, especially on CTFs. Okay, so that was our first exercise. Now the next one is really interesting. The next one is really interesting. This is going back in time, and this is for CSS. So what are we abusing? So, you know, why are we doing this? What we're doing here is we're actually doing DOM tree manipulation. Now, this can be attributed, this can actually lead to CSS injection, which is probably esoteric in some cases. Like maybe people would say, well, that's an edge case scenario, but it is a real thing. And there's actually a great blog posting about it on the Portswigger site. And it's basically called Path Relative Style Sheet Import Vulnerability. But what this is doing is we are basically going to change the CSS, you know, the cascading style sheet that is currently used by the application to be something else. And because we can do that, enables us obviously to then possibly inject, you know, malicious CSS that can have the same effect as, you know, cross-site scripting vulnerability. So that is the reason why we're doing this particular challenge. Now, how we do this challenge is, and the one thing also I wanted to point out is the reason why it's a relative path is because of the way that the CSS is referenced inside of the code. So if you look at this path, you can see that it's relative. It doesn't have the absolute. It doesn't have the slash there. I commonly mark these up on pen tests and write them up. But it's probably one of those that's underreported. So let's go ahead and do this challenge together. So what we want to do is, I actually have a helper for this because of the syntax. So you can just grab that in your README file. So how we manipulate the DOM here is you're going to hit your F12 button and make sure that you're at the console, and down at the bottom where you see the prompts, go ahead and paste in what you pasted onto the clipboard and then hit enter. And then you'll see the Juice Shop change the CSS. Now this CSS is actually being referenced from that Geo Bootstrap website that is referenced in the slides. So, and then just hit F5 to have it go back. All right, so now the next one is has a very strange title. Wherever you go, there you are. Some of you probably thought, well, I don't know what this is about. This is really about an open redirect. So, what are we abusing here? What we're abusing and the vulnerability that we're finding is a lack of a whitelist for open redirects. So basically, there are none in this application. So how we can abuse this is we're going to take a look at this link. It says there's a picture of a fork here, so a fork on GitHub. So if you right-click and you just copy that link location, open a new tab, and paste that in there, you can see that there's a redirect right here. So what we want to do is we want to change right before it goes to where the author intended it to go. We're going to put a slash to have it go to the root of the juice shop instead, followed by %00. And remember %00, that was our null byte injection. We learned about that last week. So then just hit enter. And that forces our user to come back to the juice shop. Now, of course, the implication here is that an attacker would be able to control where your users go because there's no validation being done on that redirect. So definitely a huge vulnerability. And just interestingly enough, I was on a completely different site, totally legit site, and I just happened to see the same redirect too. It's like, I have to take a screenshot. I've blacked out the name just to protect the innocent, but so this kind of thing, I mean, this is real. I know that this is set up as a game, but the idea is that by showing you these different techniques and showing you these different scenarios, these are the types of things that you can look for when you're doing an actual pen test. All right, the last one is to use SQL injection to log into Bender's account. Obviously, this is an abuse of the way that the SQL statements have been constructed in the SQLite database. So this one is pretty easy. I figured you guys already would have gotten this without much effort. So we'll start with the tick. Of course, if we just did a tick, right, and then we just did something here, we get this beautiful, beautiful message. It basically tells us exactly the way that this particular statement is made. It tells us, first of all, it tells us the name of the table where the users are stored. So the name of the table is users. Then it gives us two column names, email and password. And then it even has like this default password that's put in there, which one can only hope that it's admin, right? Which it probably is. But anyway, taking that and continuing with that, we would use our email to basically look for any email that contains the name Bender, and then we'd be able to log in as Bender. Also, you should have put in your continuation code from last week so that we can continue on together. So you should have been at about like 57% when we first started this. Okay, so now let's talk about cross-site scripting. There are basically three main types. There's reflected, stored, and DOM-based. So the reflected is where it gets, there's script controlled by an attacker that is reflected in the victim's browser only. And I sort of relate it to just having one victim at a time be subjected to the attack. Stored is more permanent, and you'll hear it called stored cross-site scripting or permanent cross-site scripting. But this is where the cross-site scripting actually becomes part of the page itself. And this is usually done by injecting your malicious script into the database itself. And then the database, of course, is used, the data that's in the database is used to render that page. And so you have the script that pops up and becomes part of the page. Very, very difficult to get rid of stored cross-site scripting once it's had its infection inside of a database. The DOM base, this cross-site scripting is going to be central to the DOM or the document, the browser, the representation of the browser. There are two caching levels related to DOM, local and session. And I just wanted to mention those. I wanted to show you in your browser how you can search for those from a pen testing point of view, to search for anything that might be sensitive in nature that could be stored there. So if you hit F2 and you go to the gear, you always want to make sure that this storage is checkmarked. So network and storage should always be checkmarked, as well as I have the DOM one there. But when you go to storage, you'll see here that there's a local storage and a session storage. Now, local storage is much more permanent. That's where it actually stays on disk. Session storage is going to die with the browser. So the idea here, and this application actually doesn't, they're not storing anything in the local or session storage of the DOM, but the idea is you can have key value pairs here. And so developers may want to put, you know, sensitive information in here to carry between page to page, right? So passwords or anything like that. Those would be the kind of things that you'd want to look for that may be stored in the DOM. So hopefully that was helpful. Okay, now our very first cross-site scripting tier 1 we did last week or the week before, and of course what we're abusing there is their lack of output encoding. So output encoding, of course, being the character representation or the character set that's being used by the web server for the rendering of the display back to the user. Now, what a lot of people don't realize, particularly with developers, is that there are many cross-site scripting contexts that have to be addressed. So from a developer point of view, increasing awareness of this is very important. So basically, from a developer point of view, you have to provide protection around all of these different contexts. I'm just naming a few of them here. So HTML element, of course, the body, HTML attribute, URL, JavaScript, CSS styles, HTML comment, VBScript, LDAP, and then there's more. So addressing each of these contexts, if you look at it from an attacker point of view, gives you tons of attack vectors. And so when you're pen testing, it's really important that you test these different attack vectors out, see if there is a vulnerability there. And I had mentioned, I think in the first session, that there are some browser protections that are put in place for stopping cross-site scripting, but you're not really addressing the situation there, right? So you don't want the browser to stop if there's a cross-site scripting vulnerability there, you want to be able to find it, you want to be able to see it. So keep that in mind for turning those things off. So the two ways that cross-site scripting is, of course, the defenses for it would be input validation and output encoding. They do go together. So let me just step you through the degrees of input validation. There's whitelist, blacklist, and none. The whitelist being the very best type. This validation, of course, is where you decide what is acceptable, what can come into the application. The blacklist is where you're just looking for the things that are bad. So always look for the word script. Always look for you know, a less than and greater than sign around the word script, you know, that type of thing. And then, of course, having nothing at all is certainly the worst. So when you're doing your pen testing, in a lot of situations, you're really trying to test if there's a blacklist there. And so in the case of a WAF, most WAFs use a lot of blacklists. Now, that's not to say that couldn't be effective, but it may mean that you have to be more creative with your payload. All right, let me just give you an idea of what I'm talking about with the output encoding and the character sets. So if we just took the word script, right, with the less than script and then the greater than sign, all of these different representations all say script, okay? So you can tell that it's really vast, it's really different. So URL encoding, it looks like this, hex, it looks like this, UTF-7, it looks like this, HTML encode, it looks like this. These are all possible payloads, payload renderings that you can use in order to get around either a WAF or a blacklist, etc. Now, I wanted to go into this because, in my opinion, this is one of the most underreported cross-site scripting vulnerabilities, at least at this time. And basically, that is a mismatch of character sets between the request and the response. So let me just explain what this is. So you have to tell the browser what kind of character set to expect. If you don't do that, so this is coming from a developer point of view, if you don't do that at the web server level, because this should be set at the web server level, then what the browser will do is it will guess. And when the browser guesses what the character set is, that can lead to cross-site scripting. If you think back on those different renderings of the word script, that's where this comes in. And there's also a link here of Google's cross-site scripting vulnerability that has this very problem in there. So take a look at that read. So what you would do is at the web server level, or you could do programmatically, you would set inside of your header that defines the content type, you would also define the character set. And as I said, the character set that you use for the request needs to match the character set that you use in your response. So if you find mismatches or you find omissions, then you definitely need to write it up as a vulnerability. Now, some of you are wondering, well, what kind of character set should I use? Usually UTF-8 is universally accepted, and then also the ISO 8859 for Western Europe. Those were the two main ones I think that are used most often. All right, so now we're coming into another cross-site scripting. This time it's going to be in the registration form. Now, what is it that we're abusing here? We're going to be abusing a lack of input validation. The challenge says perform a persisted cross-site scripting attack, persisted meaning it's going to become part of the page, with this payload by bypassing a client-side security mechanism. So client-side security mechanism could mean that it's in JavaScript or it's something just at the web page level. So what we want to do is, in order to do this particular challenge, we want to go ahead and let's log out, because we can't be logged in to register a new person. So you click the login, but you go to this register now link, and it takes you to the user registration. So let's go ahead and I actually want to show you, there's kind of an easy way to do this, which is using the proxy interceptor, which we've used in the last couple of weeks. But I actually want to show you how to do this using something called Postman. So now, why am I showing you a different way to to do this. Why do I show you different techniques? In all of these sessions, I'm trying to show you different techniques because it's different ways of looking at the problem, especially when it comes to Angular and HTML5 type applications, because chances are they will have an API component to them. And that's really important because a tool like Postman will help you to test that API component to see if the validation that's being done in the UI is still available in the middle tier, right? So, and in this particular situation, that's exactly the case. The developers put validation in the client, on the client side, but they didn't put it in the middle tier. They didn't put it where the API calls were made. So that's how we can circumvent it. So if you don't mind, what I would like to do is actually do this challenge using Postman. Now, if you'd like to follow along, you do need to untether Burp from Chrome in order to use Postman. So let's go ahead and do that together real fast. It'll just take a moment, but you'll open Chrome. By the way, Postman is a plugin for Chrome only. So that's why I had to install Chrome. Go to the three dots, go to Settings, go to Show Advanced Settings, go to Network, change proxy settings, go down to Network, and it may be set to manual. You don't want manual. Just set it to none and click Apply System-Wide. It's going to prompt you for the OSBox's password. Go ahead and put the password in, and then you will be untethered from using Burp inside of Chrome. We don't really need it. I only have Chrome installed just to use Postman. Okay, so you're going to start up Postman, and I'm going to step you through how to do this. Now, in order to make this super easy, what I want to do first is go ahead and do a registration with my proxy, my Foxy proxy on. So I'm just going to do Bob. I guess I've made Bob before, so maybe I'll do Bob4. Password 8 ones is fine. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And click Register. Okay. Now, if I go to my proxy tab and I go down at the end of my proxy history, I can see the request that I just did. Let's go ahead and send that to Repeater. Okay, and we don't actually need to send it. I just want to see this for the construction of the request, so I can put that in Postman. So let me put that in Postman. So first of all, notice that this is a post. So the verb I'm going to use in Postman is going to be post. We're going to copy the URL. Copy URL. Okay, and you can see that I have data. I mean, obviously it's a post, so I'm going to have post data. And it is a JSON structure. So I'm going to copy that payload. Now what you need to do in Postman is go to Body. You need to select Raw. When you select Raw, there's a drop-down list over here. You need to change from text to JSON. And then paste in the JSON structure that you got over from Burp. Now, we need to put our payload in here. So if I go to the scoreboard, I'm going to grab this payload. And I'm going to place it right here. Now, one of the cool things about Postman is it immediately has this little red X. what this is telling me is that my JSON is not, it's not correct. There's something wrong with it. And I highly recommend that you grab hold of a good JSON validator. There's tons of them online that you can use for free. But here in this case, what it wants me to do is escape my quotes. So put an escape before the first double quote and another escape before the second. And now you can see the X has gone away. So all we're going to do is go ahead and send this. And we did receive a successful message. And you can see that now in the database, I have permanently made as my username this malicious script. We're going to be using Postman quite a bit tonight, so keep that handy. If I come over to the juice shop, you can see I'm getting the successful banner now. Okay. Now, the next one is where we're going to do cross-site scripting in the feedback form. And it says, perform a persisted cross-site scripting attack with the following payload, bypassing a server-side security mechanism. So this goes back to the blacklist that we were talking about. One thing that you should be aware of is, so like in the .NET framework, if they do like a validate request, that's actually based on a blacklist. Maybe a lot of people don't realize that. So this is kind of in that same vein. So what we're going to do is we're going to go to the Contact Us form. I'm going to get rid of this banner. And how I want you to construct this payload is start off with a ending bold tag, okay? And now do a second ending bold tag, okay? Now I want you to go grab the payload, which is 4. Okay, put that payload right in between those two bold tags, those two ending bold tags. Now, what we're going to do is we're going to move the opening left, or the opening less than sign of script, and we're going to move it to the outside of this ending bold tag. And then we're going to take the closing script tag, and actually we're going to take the closing script tag but not its beginning less than sign and place it there. And let me just make sure. Yeah, so now when I submit that, you can see that I've bypassed the blacklist. So the blacklist was only looking for, you know, less than sign and then some words. But when we do the double less than signs, we're able to get around the blacklist. So definitely try these types of payloads, particularly if you know that there's a WAF in front of an application. If you want to try something different, see if you can get around it. Okay, so now let's move into more JSON injection stuff. As we get more into the JSON injection, it really makes it a lot easier to use Postman. Certainly you can use Burp, but when you start dealing with REST calls and you know, straight API calls, you really want to use a tool that is more designed for that. Burp can augment stuff once you're comfortable making those calls. But it really helps to kind of start with Postman. So JSON, it stands for JavaScript Object Notation. What you do need to keep in mind is your content type is always going to be this application JSON. I did mention to you the validation of JSON and how important that is. There's, as I mentioned, tons of formatters and validators online. use them. They're very good. Some of them are very good. Okay, so this next exercise asks us to get rid of all five-star customer feedbacks. Now, let me first explain to you the problem with this particular page. Do you guys remember when we found this admin page? Let me see, I'll just bring it up here. Do you remember? Oh, see, isn't that nice? Now I have a cross-site scripting pop-up. Do you remember this page? So it was the /administration. Now, I am not logged in right now. And if I try to delete this 5-star feedback, I actually don't get any kind of message in the UI. But if I look at this call in Burp, if you go down to the very bottom, you can see that there's my call. Okay, it's an API call. It is a delete, right? And I'm trying to delete the number one, the comment that's labeled number 1. So this was my request. In the response, what I got was no authorization token was found. Wow, interesting. Now, one thing about this page is whenever you're using Spider or you come into a situation where you don't have maybe a CSRF attack or a CSRF token rather, or a session token, or maybe Spider has logged you out, all of those situations are great scenarios for where a Burp macro can help you. So Burp macro is basically a way to take a series of events and play them again, kind of like a recorder. And this would be a good place. So if I were spidering or scanning a website and I wanted to make sure that, hey, if I accidentally do hit something where I'm not authorized, I'd like to have a macro sort of just jump in there and run for me and put me back into a live session so that I can keep going. So that's kind of food for thought. We're not going to get into macros in this session. We don't have the time, but that's kind of what the idea is behind that. Okay, so having found this, we realized that in order to do this through the UI, we would have to log in as admin, which we could certainly do, and then we'd come to this page, and then we'd click this little trash can. But that's like super easy. So that's the easy way to do the challenge. Let's see if we can do it a harder way. This is showing you how to do the challenge through Burp, and I sort of labeled it medium. So the first way I said was easy, and this is CSRF, by the way. We're going to do a CSRF attack here or replay attack, however you want to look at it, because there's like no validation done on the admin's token. But anyway, so the medium way would be to do it through Burp, but let's go ahead and do it the hard way by using Postman. So what we're going to do is we're going to take this request. Let's just go ahead and send that to Repeater, just because it's just so much cleaner to look at it in Repeater. And we'll bring up Postman. Open a new tab by just clicking the plus sign. Now we are going to do a delete. And I'm going to copy the URL. And now, you would think that you'd have to use an authorization token, but actually, in this particular application, they're just using the authorization token as a header. So this is actually some sort of service, I guess, that you could call, but we don't need to use that. We're just going to add our header in. Now, interestingly enough, I haven't logged in as the admin yet, so I don't have that token. No problem. Let's go ahead and go to the login. Let's log in as an admin. Remember, our password is admin123. Okay. So if we take a look at our HTTP history, we can see the post is admin. And in that response, you can see the token. And if you take a look at the very next request, which is basically the default search as you come on this page, you'll notice that there's a special header here called authorization. That's what we want to grab. So let's copy that name of that, and we're going to place that in our Postman. And then you need to grab the word bearer, because it is a bearer token, and go all the way to the end and copy that token into the value box. Okay, so we've got our delete. We're trying to delete the feedback that's represented by the number 1. And we have our bearer token as admin. So let's go ahead and hit send. And we get a success. If we go back to the scoreboard, and you may have to refresh, you can see that we solved that challenge. Now, you get a couple of, you might get a couple of duplicate banners there. I think it has just something to do with the way that they wrote the API calls. So don't really know for sure, but anyway, you got 3 different ways of solving that challenge, which is, remember, 3 different techniques that you can use in a pen test to find vulnerabilities. So just a little bit of information to give you if you are going to do a pen test against some REST calls. What I do is I really challenge the API calls by trying all of these verbs. So it should be set up where the REST call should have a list of particular verbs that the only ones that it accepts. But I don't let that stop me. I still try all of them. And the reason why I do is because even if I get an error message back, I want to see what that error message says. Is it a 403? Well, if it's a 403, then that's something I would, that could be a carrot, right? There's something more there, so I would probably write that up. Or does it show me a stack trace? Does it, so even in error messages, there might be something that could be found. So I always try them all. Takes some time, but with Postman, it makes it really easy. Okay, so let's go ahead to the next one. This is just showing you, that in the UI, without being logged in, we saw that no authorization token was found. But you saw that I was logged into the GUI, right? And I did the command from Postman. So there's no kind of anti-CSRF token that's being used. In fact, we could do an entropy test of this token, which we're going to do with Burp Sequencer in just a moment, just to see how bad it really is. So let me see if I've got, yeah, so that's right now. So let's go ahead and do that together. Do you guys have any questions so far, or?
Nobody said anything in the chat window yet, so I think we're okay. If anybody has any thoughts or suggestions or anything, you can hit me up privately if you'd like. Okay, great. So what we want to do is, do you remember that post where we logged in and we got this token? What I want you to do is I want you to send this to Sequencer. Now, Sequencer is really cool. This enables you to test the entropy
of any kind of token that you might find in a response. And so what we're going to do is, because Sequencer will automatically try to find what the token is if it's a cookie or whatever. But if it can't find it, then you have to tell it where it is. So we're going to go to the Configure tab. And what you'll want to do is highlight the token, but you don't want the end here. So let's see if I can do this. Actually, we just want here. Okay. And we could stop it here if we didn't want to include the rest of it, but we'll just take this whole thing. And you can see at the top that it says start after the expression token, right? And then the first opening double quotes, and then end at delimiter, and that it ends before the ending double quotes. So that looks good. So we'll click OK, and then we'll go ahead and start the live capture. So what Burp does is it starts sending a bunch of requests, collecting the token that is in the response. Once you've collected a minimum of 200, you only need 200 to start your first analysis. What you'll do is just click Analyze Now, and it's going to tell you just how strong this token is. So what it says is the strength of this token is extremely poor. The amount of effective entropy is 0. And that's because it's always the same. But this I thought was a good exercise because as a pen tester, this is definitely something that you should take advantage of looking into whenever you find any token, whether it's anti-CSRF or session token, just run it through the sequencer and just see, how strong that thing is. The barometer or the standard is it needs to be around, somewhere past 114 to 128 bits is considered, strong. But I mean, not that you have to get deep into the math, but at least if you can let them know if it's a weak token and easy to predict or easy to break. So that would be good to include on your pen test. Okay. All right, so now we've got another challenge where we're going to abuse some more HTTP verbs, and this goes back to when you start testing REST APIs. This is the kind of thing that I do. So the challenge says we want to change the href of the link of the OSALT product, and we want to change that value to go to a completely different URL. So what is the problem we're trying to solve? What is it that we're abusing? We're abusing the lack of an auth check, basically, in the back end on a particular HTTP verb that we're going to use. So in other words, the developers need to be doing authorization checks on any kind of call that comes in, right? They need to check, well, who's making that call? Do they have the authorization to actually modify or manipulate that information? So in this particular case, we're going to use the put verb. So how you can go about doing this is, first, let's go back to the main page, and I want you to scroll down to this OSALT, and click the eyeball, and then close that, and then find that same call in your proxy HTTP history table. Okay, so this is the call. Let's go ahead and send that to repeater. And actually, this is the get. So let's just click go and do a baseline. Okay, this is just the get. So we could reconstruct this inside of Postman, but what we're going to do in Postman is we're actually going to manipulate the information, right? So go ahead and open Postman. Open a new tab. And we want to change our verb from a get to a put. So a put, if you don't know already, put actually manipulates or modifies the data that's in the database, that's on the back end. So we're going to do put. Let's copy the URL. We're going to paste that here. Get rid of the question mark in the date. We don't need that. So your URL should end right at the number 8. And what we're going to do now is we're going to take this response, all this JSON, right? Just go ahead and copy that. We're going to go to the body, raw, change from text to JSON, paste that in. Now, we really don't need all this information, and just to make it cleaner to read, I'm going to put everywhere there's a curly brace, I'm going to put that curly brace on a new line just so that I can more easily read this. This is kind of where those JSON validators really help to kind of help you read all of this. We don't need the first part at all, so we can delete that along with its ending curly brace. Inside of the data, we're not interested in the ID field at all, or the comma. We're interested in changing the description. So that is the only parameter that we want to leave here. So everything else, including the commas and the price and all that, we just want to get rid of. Okay. Now, the challenge says that we have to change this particular link to be a completely different link, right? So let's go back to the scoreboard. Let's go grab our payload. We want to leave all the things that they have in there for escapes, right? So that ending escape. And let's just paste in our payload. Okay, and then click send. So quite worrisome here. That was a success. So I have I have no authorization token. I'm not logged in, and I just changed the data in your database, right? How scary is that? So, and if we come over here, of course, we'll get our banner. I'll just refresh this. Right, so we changed the link. So, so this is definitely missing authorization checks or access controls. A very good find. So, so hopefully that will be helpful for you on your pen test. And these next couple of slides just kind of step you through how to do that.
Sunny, I have a question. Where does one get the Postman application? You said it only works in Chrome. Is there a website for that?
Yeah, you can just go to add-ons for Chrome and type in Postman, and you can add it in.
Okay, excellent.
In order to use it, you do have to sign up. The gentleman that wrote it, he actually does a really nice job of updating it. It also has an interceptor in it. You can pump it through Burp, which is what I had done with a previous class. That's why I had you untether it. But it's really a really nice tool. And if you're If you do a lot with HTML5, there's almost always going to be a /API directory, and so you're going to want to use something to help you with those calls.
Okay, and that's is there any equivalent in Firefox that you've been able to find that works similarly?
Yes, I've used something called a REST client. I can't remember exactly. I'll have to put it in the channel for you. It's okay. I mean, it's good in a bind. If I can't use Chrome for some reason, it'll help. But this is definitely my favorite because it has so many little nuances with, you know, validating my JSON and things like that. Which really saves a lot of time because I've spent some time, you know, trying to sort out if my JSON was right or not, and you don't have time for that, you know. So
sounds
really
good.
good tool. Yeah. Okay, so this one is where we're going to basically use the same payload to deliver another persisted cross-site scripting attack, which we know becomes permanent in our page. But this time it says, perform a persisted cross-site scripting attack with this payload without using the front-end application at all, which of course we know, great, we're going to be using the API. So, and of course, what is it that we're abusing here? What's the vulnerability? The lack of both input validation as well as output encoding. Now, some developers might make the argument, well, you know, it's JSON. Now, why do I care if, you know, I'm not displaying it back to the browser. This is an API call. Why do I care about cross-site scripting? So what you have to keep in mind is that, first of all, once it's in your database and it's tainted your database, it's really, really hard to get it out. I don't know if you guys remember the SQL Slammer. It's been, I don't know, 15 years, Brian. I don't know if you remember SQL Slammer, but
oh yeah,
I mean, that thing, it still resides in databases today, and it's basically malicious JavaScripts that I think they like base64 encoded it or something like that. But anyway, what happens is in large companies, in small companies, once data is in a database, that data gets reused again and again and again for other applications. And they even call it delayed cross-site scripting. So even though you're not displaying it back to a browser in this immediate application, it doesn't mean somebody won't come along later on, reuse that data, and boom, they've got a cross-site scripting vulnerability. So, so we just don't want it there in the first place. Okay. So in order to do this attack, we are actually going to reuse this same payload in our Postman. So let's just go ahead and grab this, copy, and I'm just going to replace the entire string in between the two double quotes and paste my script payload. Now, once again, I get the little X, so that means I need to escape my double quotes. I'm going to do that and go ahead and send that. And voila, I have manipulated the data once again without being logged in or anything. So it looks like I got credit for that. Okay. All right, so now let's talk about Burp Extenders. So Burp Extenders are also known as plugins, and what they do is they really are nice for integrating with third-party tools, which we're going to use one of those with SQL Map. And you can write your own Burp Extenders. I have written my own. They cover, basically, they're available for Java, Python, and Ruby. I will be doing an extensive course on writing these along with macros. Over the next several months, I'll be writing that course. But it's really, really interesting. This is when you start realizing, hey, maybe there's not a certain plugin out there that does exactly what I need for my business. So I can just go ahead and write one up. So all the interfaces, all of the blueprints, if you will, are provided to you by Portswigger, and then you basically just call what you need it to do. So the one thing I wanted to remind you though is you can have plugins, you can write custom extensions, and you can use free or you can use pro, but it depends on what the functionality is you're trying to call. So if you're wanting to call Scanner, you're going to have to run that plugin in Pro, because that's where Scanner is available. So just bear that in mind. So what I wanted to do is I wanted to kind of give you just a quick overview of extenders and the B App Store. So the B App Store is where you have all of these different plugins available. Now, for our purposes tonight, we are going to use an extender called CO2. It's written by Json Gilliam, and I believe he works for Secure Ideas. He's very nice. I've actually reached out to him in the past and asked him questions about his plugin. But what you'll want to do in order to get this working on your VM is you may have to update. You might see an update button here. So go ahead and click that and make sure that it's check marked here so that you can do the next exercise that we're about to do. So you will also know what extensions are loaded by going to the Extensions tab. This will show you all the ones that are listed, that are installed, as well as having that check mark there lets you know that it's actually loaded. And this is just to kind of help you with that. Okay. So what we're going to do is we're going to use SQL Map. SQL Map is an awesome tool that's written in Python, and it basically performs SQL injection for you. So what we're going to do is the challenge of retrieving private data. So the first thing we want to do is we want to log out of the application. The reason why I'm logging out is just because it makes everything cleaner when we go to do the attack. Now, the only box that I could try SQL injection on this page with is the search box. So let's just put a simple search request in there. It could be any kind of string that you want. I'm just going to type my big search and then click the search button. Of course, I don't get anything back. That's fine. Now, let's go to the proxy tab. Let's go all the way to the end of our HTTP history. Find that request. Okay, now what I want you to do is right-click and send that to SQL Mapper. So SQL Mapper is part of the CO2 library that Json wrote. Now, the first thing that I want you to notice is this SQL map command up here. Now, what it's done is it's automatically put this cookie in there. I am not interested in that cookie. Okay, so uncheck the include so that it cleans it out from the top. Now, the other thing that we need to do is that the higher that you go as far as detection levels and risks, the noisier you're going to be. But we do have to at least select one level of risk. So let's just stick with 1. Now let's go to the injection tab. Now, testable parameters, these are the parameters that you want SQL Map to test for to see if they're susceptible to SQL injection. Well, in this particular string, I've only got one name value pair, right? So my name or my parameter is Q. That's the only one that I can test here. So I'm going to put Q there. My database on the back end is SQLite. So let's go ahead and put that there. Okay. Now, there's a couple of different ways that you could run this. You can certainly configure SQL Map to run right from Burp, and there's nothing wrong with that. But the way that I've been doing it is once I get this string constructed the way that I like it, I'm going to Control-C and copy that. Make sure that you're logged in as root, and just to show you that SQL Map is loaded in there. Put a space and then paste that string and then hit enter. Okay. Now, SQL Map does do caching of results. So what you're seeing here is a caching of those results. There's a way that you can go and delete the file that has the cache if you want to run it all again from scratch. Completely up to you. But what this does is it lets us know that this parameter Q of the method get is susceptible to SQL injection, and it was done, the blind SQL, if you will, was done using a union query. So that generic union query, and it does all sorts of different types of attacks, SQL Map does, so take a look at that if you're interested. But this is really important to us. It lets us know that in this product table, there are 8 columns. So that's important because when you start trying to do blind SQL injection, you've got to, at a minimum, know the number of columns that you're trying to hit. So what we want to do from here is we want to copy all of this. We want to, I'm just going to put it in this notepad here. Actually, I'm going to copy it twice, so I'll have the original. I'm going to make note that we had 8 columns. Okay. Now, I don't need this at the end. This payload here that they're getting a totality of truth on, I'm just going to remove that and replace it with null. So I want to make sure I've got my 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, if you remember when we were at the login page and we just put a tick here, right, and something here, we get this error message from SQLite. And this error message told us the name of the user's table. So the challenge that we're trying to do is to divulge some private data, some sensitive information. So we know that we want to try to search against this user's table. So let's go ahead and add from users here. The other thing that this very informative error message tells us is 2 of the columns. So 2 of the column names are given to us. Well, if we assume that the first column is probably some row number, then email may be our second column. And hopefully password is our third column. So now let's try this string. Inside of our search. And here you can see we were able to retrieve a list of all user credentials using SQL injection. So what you're seeing here is that same information that we saw in the administrative screen not too long ago, right? So of course these column names don't match up because we're using a completely different table screen to to view the contents of a completely different table. So, but anyway, that's how you solve that one. And if you're interested in getting more into SQL injection and blind SQL injection, I have here a place where you can read more on union statements and constructing them, particularly in SQL injection cases. Personally, I love Pentest Monkey. It's got every other database actually except SQLite, but it's great because he basically provides so many kind of queries that you would want to do in order to discover, you know, can you get to the root shell, you know, all those kind of things. He's got all of those in cheat sheets for you. So check that out. Okay, so now let's do a summary of all the things that we've learned over the past 3 weeks in these sessions. So what exactly did you learn in this course related to Burp? So we learned how we can configure all of those Burp options. So there's an option for Spider, there's an option for proxy, there's a scope tab, there's the sitemap. So all of these things are really important that you configure properly and that you configure them first before you start your pen test. Together, we used the repeater, the intruder, the decoder, the proxy, the spider, the extender, and the sequencer. That's a lot. I mean, we pretty much exhausted almost everything that you can do with the free edition. So there's more stuff obviously in the professional, but that would be for another class. What else? We learned how to use Burp to manipulate hidden fields, JSON structures, URLs, get post parameters, as well as headers, right? We've added headers, we've taken headers away, etc. And then finally, we looked at how we can use Burp plugins like the SQL Mapper to ease the use of third-party tools and other attacks. All right. What did you learn in this course related to HTML5 and these heavy JavaScript applications? Well, the first thing is we realized that we need to do a lot more manual triggering of events because the JavaScript heavy applications require that sort of event triggering mechanism. The other thing that you should have realized is that HTML5, these applications are still prone to the same vulnerabilities, right? So there's no free card here of getting past them. So we still saw that, you know, we can bypass client side as well as server side validations. The server side validations, of course, are some blacklists. So the same problems can still be there. Problems with SQLi, a lot of poor session management. The one thing, too, that I wanted to stress is that these HTML5 applications are more than likely going to have a REST API component. And so that has to be tested. And that's why we went through all these exercises using Postman so that you can get familiar with that tool and really invoking those calls as they should be tested. And also the testing of the use of OAuth tokens, right? And checking for weaknesses, whether it be in the entropy or just whether it be the way that the initial OAuth account is set up. So if you remember the CISO abuse, right? We just added a custom header and we were able to log in as or become the CISOs, the CISO. So, all right, what else have we learned? What did we learn in this course related to OWASP vulnerabilities? Well, what I've listed here is actually the latest version of the top 10, and that is for 2017. So let's just kind of go through some of these. So A1 injection. So A1 injection, we did a lot of SQL injection exercises. I also showed you JSON injection exercises. And so we looked at different techniques of even how to do those. All right, what about broken authentication and session management? Well, if you recall, we ended up accessing someone else's basket. We put feedback in somebody else's name. I mentioned the OAuth bypass with the special header. We also did the replay attack, right, with the admin's token. All right, how about cross-site scripting? Well, we had 4 tiers of cross-site scripting, different types. I also introduced to you the relative path of the cascading style sheets. So that's a different type of cross-site scripting I introduced to you tonight. And as far as broken access control, we were able to access the Pound administration console without being logged in at all, right? Now, we couldn't actually do anything. Like we couldn't click the garbage can to delete that one response or that one feedback, but the fact that we were unauthenticated and we could access administrative functions is very bad, right? That's certainly a vulnerability that we would write up. And also we saw how we can do the put rest call and modify information in the database, and there was no authorization check. Security misconfiguration, A5. That would be the lack of the setting of the character set. Remember I talked about that the character set needs to be the same for the request as well as the response. And that's usually something you would set at the web server level. Also, there was no content security policy set for our DOM manipulation, which certainly could have helped. I didn't get into CSP much in this course, but that's certainly something that we could tackle at another time. Sensitive data exposure, of course, that was the giving up of the users table that we just did using SQL map. Insufficient attack protection, this is one of the new ones. So this is really, this particular category, which is a new label, it basically means you don't have any anti-automation protection, right? So we've been able to very freely use Burp Intruder, and we've never had any kind of velocity check or account lockout or shunning, you know, of our number of requests. I mean, the only shunning that's happened is with Burp from using the free version. But from the application, they don't have any kind of anti-automation in place to protect them against that. The cross-site request forgery, this is the changing of a user's password. This is something that I've set as one of the homework assignments, but basically we're able to change one of the user's passwords because A, there's no validation being done of the previous password, and B, there's actually not even the validation of the existence of the previous password, and we'll see that in the homework. A9, using components with known vulnerabilities. This has to do with, if you recall, that package.json.back. In there was a list of dependencies. What you would do if you use something like Wappalyzer, which is something that I introduced the very first day, Wappalyzer helps you to fingerprint a web application to identify all of the different libraries that might be used there. What you would want to do is you would want to go through that list and start Googling on the open source vulnerability database to determine what known vulnerabilities there are associated with those packages. And so those are things that you would include in your report. So it could be jQuery, it could be anything like that. And then finally, A10, underprotected APIs. I think we saw that quite plentiful with abusing the puts and not even being logged in. So hopefully that helps you to feel like you got a lot out of the course in not just content, but as well as the different techniques that I've shown you. Okay, so technically that's the end of the content for session 3. this is now the homework, and I was just going to go through the homework with everybody since we're not meeting again. So if everybody's okay with that, I'll go ahead and proceed.
Yeah, give us about a 5-second block. That way, if people want to do the homework and then come after and follow this, then they can just pause it here, and then we'll then they can start. So
sure.
Okay, so there's spoilers after this. If you haven't done the homework yet, pause it now, or spoiler alert.
All right, thank you, Brian. Okay, so the first homework assignment is to log in as Jim. This is going to be very similar. Of course, what are we abusing? We're abusing SQL injection again. This is going to be very similar to the way that we did with Bender. So so if we go to the login page, and just get rid of this banner, and we do our tick. Now we're going to just have the like statement look for anywhere that Jim is found. Of course, Jim is a common name, but lucky for us, there aren't any others. Of course, you can put anything you want here in the password box, and then we're logged in as Jim. Now, the next one is we're going to log in as Bender, and we're going to change his password. We have to change the password to this Slurm Classic. So we're going to use SQL Injection to log in as him. Then we're going to go to the change password form. And this was one of our CSRF attacks. Now, if you do buy Burp Professional, there's a CSRF POC that comes with it. And it really helps you to play around with anti-CSRF tokens, omitting them, putting them back, changing them, seeing what kind of response you get from the application. But we don't have that, so that's okay. We're just going to use repeater, which is fine. So what we want to do first is log out and log back in as Bender. Put anything here for the password. Go to the change password screen, and we're going to find this in our history. So I'm going to put all ones for the current password. Obviously, I don't know what the password is, but I'll just put 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Now the challenge asked us, and let me just bring up the scoreboard again. Okay, so the challenge asks us to change the password to this Slurm Classic, so I'm just going to copy that. Put that in for the new password and click change. Of course, it's incorrect, but I'm going to come to the location where that request is. I'm going to send that to repeater. Go ahead and click go to baseline this, so current password is not correct. Now at this point, if I had Pro here, I would use my little generate CSRF POC, but that's okay. The idea would be you would start playing around with any kind of anti-CSRF token available, which of course this doesn't have. So. But what we're going to do is we're just going to try and see if the developers are even checking for that current password. Now we know that they're checking at some level on the UI, but are they doing it past that? So if we remove that and then click go, you can see that we get a completely different response. So we've been able to change his password. And this may seem far-fetched, but there was actually a website where it was a shopping cart, And in order to bypass their authentication, all you had to do was remove one of the parameters just like this, and then you could basically get onto the shopping cart website without even being authenticated. I mean, it was crazy, but it was a real site. Anyways, the same kind of idea. So this stuff has happened. So that's how we would go about solving that puzzle. And this is just a little bit of information of, if you go to the GitHub site, you can then look at the source code behind this whole application, and you can kind of see the mistakes that the developers made, obviously intentionally, because this is meant for instruction. So, all right. The next one is identifying those vulnerable libraries. So when you look at that JSON backup file, or even if you use like Wappalyzer, like I mentioned earlier, what you would find is the two answers that they want is this Sequelizer 1.7, which is used for the API calls to SQLite, and this Z85 0.0, which is that strange encoding that they use to create the coupon codes. So in order to get credit for this, what we would do is go to the Contact Us and type in Sequelize 1.7 and Z85 space 1.0 or 0.0. Okay, and that gives us credit for those two. All right. Okay, the key pass program. This one is really involved, and I'm not going to go through the entire exercise. I'm just going to kind of talk you through it. But basically, what we're abusing here are really weak credentials. What you'll do is, the challenge says log in with the support team's original user credentials without applying SQL injection or any other bypass. So they, if you remember, when we found that /ftp directory, there was a KeyPass database file that we could download. Well, you download that. Then you have to go searching through and find the Romanian version of the website. Remember all the languages that drop down. And in one of the comments, there's this clue. And it basically, and the clue is in Romanian. So you still have to run it through a translator. But it says support team or key file using the agreed and leave the password blank. So they're not going to use a password in the KeyPass program is basically what it's trying to say. What turns out to be the key to the database of the KeyPass program is the picture of the juice box. So that's the key. So what you would do is, of course, you need to download the KeyPass program, load that, that database file into it, and then use that image as the key. And once you do that, you are able to see the encrypted, if you will, password of support. And this is the value here, right? So what I did is I put this in your little README file just to kind of help you out. So you can just copy it here. Go to the login page. Of course, we have to log out as Bender. We don't need to be Bender anymore. We want to log in as support. Paste in that password, and that solves the challenge. Okay. This last one is having to do with how they created the continue codes. So once again, this is, we're abusing a weak cipher type situation here. They used something called hash IDs as something open source that's available. So you go to this website, you click this check out the demo link, and the page that it takes you to actually has some JavaScript in the far right box. What you would do is modify that original JavaScript to values that match the challenge. So they want you to have the continue code for the challenge number 99, which doesn't actually exist. So what you would do is you would change the numbers 1, 2, 3 that are in the demo box, you would change that to 99, and you would change the size of the continue code, or in this case, the hash ID, from 8 to be 60. And that gives you this really long string. And of course, out of convenience, I have placed that very long string for you in the README file. So what you want to do is go ahead and paste that in and click Restore Process. And you should get a banner for that. All right, and there you go. 100%. So, so we've completed all the challenges, and congratulations for making it through the course. I think I mentioned everything that I wanted to, although there was at the last minute, someone had asked about core calls, and so I just wanted to mention that when we looked at the application architecture for this HTML5 app, and when we did the spidering, remember that there was that /API folder. So that was your clue, right? That they're definitely doing API and REST type calls. And whenever that comes into play, you do need to check for CORS, or cross-origin resource sharing. CORS is designed to basically make it easier for other entities to use your API calls, but it does have some. It can be implemented the wrong way, and many times I see it where you know, the wildcard is used to just allow any domain in. Think about how these applications might be configured, might be set up, even from a networking perspective. So in a lot of situations, you know, if the application is behind a reverse proxy, that makes the setting up of whitelisting of domains quite easy, because it's just going to be, you know, whatever the domain is of that reverse proxy, which is usually, you know, the company that owns the application. So there's a lot more about CORS that I could go into, but I'm going to go ahead and stop it for tonight. So I do hope that this has been informative and educational for everyone. So thank you for your attention.
Excellent, excellent. So so Sunny, after the class is over, if people are watching this video on YouTube in the future or anything like that, is there any way they can get a hold of you, or if they want to ask some additional questions? I'm hoping you'll have a throwaway email instead of an actual email like your personal email or anything, but you know, any other contact information would be great for people who are having questions.
Yeah, so you can DM me at SunnyWare on Twitter. That's a great way to get a hold of me.
Mm-hmm. Okay.
Yeah.
Cool. So yeah, thank you, Sunny, for teaching this course. I know I've learned quite a bit. I'm going to go back through all these videos and run the labs again. This might be a good precursor if you're thinking about doing, say, you know, Sec 542, which is the GWAP pen test course. So I'm not saying that this would be a prerequisite, but if you're wanting to prep for that and you don't understand a lot of the concepts and topics that you're expecting to find in the GWAP course, this might be something you'd want to use to maybe figure that out, or to get a good handle on Burp, because I know they use it a lot in that class. So
Yes.
yeah, again, thank you, Sunny, for joining, and thank you to all the students who've joined us here. So I'm going to go ahead and stop the recording. Please, if you're liking this content, please join us on the BreakSec podcast. We're at breakingsecurity.com, BRAKEING security.com. And we're on Slack, breaksec.signup.team. So if you're interested in joining everybody in the conversation over there. So thank you for listening, and thank you for watching the videos.